Hey guys, welcome back to AlgoYogi. We are doing binary search now. You know what I'm saying? Just kidding. I don't have that vibe. So our third problem is guess number higher or lower. And if you were a cool technology kid, when you were young, and of course you were young when you were a kid, you must have played this game. You ask somebody to think of a number and you want to take minimum number of attempts to guess that number, right? The only thing is, like, the person who is choosing the number, they are allowed to tell you if the number that you guess is higher than the number they picked or it's lower than the number they picked. And if it is equal, they just say. So that's the exact problem right here. And we gonna solve it so good. We're gonna do it like so good. What am I doing? Okay, so we are playing the guess game. The game is as follows. I pick a number from 1 to n. You have to guess which number I picked. Every time you guess wrong, I will tell you whether the number I picked is higher or lower than your guess. So basically, you call a predefined API. This is a really good way of integrating APIs into the function, because it's all about, like, in the real world programming, it's all about calling APIs, right? So it's a good way of integrating here, that they give us this function sitting on somewhere on the server running. We call it, we give it input, and it gives us an output. That's the whole point of, like, API, right? Okay, and which returns 3 possible results. So -1, your guess was higher than the number I picked, so that means you gotta come down basically in terms of guessing that number. And if it is 1, that means your guess was lower, you gotta go a little higher, than the number that you just basically guessed. And then if it is 0, then the number is basically correct, what we are guessing. All right, so as you can see over here, basically this is the pick that the person has done. This is the range, basically from 1 to n. N is basically 10 in this case. And of course, we're gonna guess 6, but how we make that decision that we end up with 6 with least possible guesses. So if n is 10, you don't want to make like 10 guesses, because any stupid would do that, right? You don't want to make 10 guesses, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, is your number, what is it, your number? Like 1, 2, 3, 4. That's not what we're gonna do. We're gonna use technology, which is binary search. You know what I'm saying? I'm not saying anything. Let's show you guys. So here is our range. So it's our job to guess the number, right? So somebody just picked 6, and we have the range from 1 to 10 to basically these are the number that somebody must have picked, although they're telling us the pick, but we wouldn't know, right? Okay, so how are we gonna actually guess the number right in minimum guesses? We're gonna use binary search. And how we do binary search is basically we find out the middle number. Sorry, got too excited. We find out the middle number, made that guess. Is that the pick? If it is, return the number. If it is not, then we're gonna get either negative. We're gonna get either -1. We're gonna either get +1, or we get 0. And each of these return signs basically mean different things, right? -1 means that our guess was basically too lower. We gotta go higher. And if it is 0, then it's equal. And if it is basically +1, then our guess was lower than the number, and we gotta go a little higher. I think did I say the same thing for the -1? -1 is like your guess is higher and got higher than the number they picked, the algorithm picked, and we gotta come basically in the first half. So what we're really gonna do is, so let me write down this. So 1, write down the exact range. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? So how are we going to use binary search? First thing is we're going to have a while loop. Let's have our left pointer pointing to the first value, and then we have our right pointer pointing to the last value. Then we find out the middle, which will be basically left plus right divided by 2. This is what we will give us middle, and in this case it will give us 10 plus 1 divided by 2 gives us basically 5 point something, but 5. So 5 is here. Is this our number? We're gonna send this to our guess API like this. Then this will return us either of these numbers, right? But you can tell, since this number is already basically lower than our guess, so it's gonna return us 1. This will return us 1. Then we would know that our guess was basically lower than what the actual pick is. So we will move our left pointer. We will move our left pointer to basically mid plus 1, which is 6. So mid was 5, 5 plus 1, 6. So this is our left pointer now. Right pointer stays same. Then we're gonna find out the middle here. Middle would be 6 plus 10, 16. 8 is the half of 16. And this is our new middle. We're gonna send it inside our guess. And this time it's gonna return us -1. This is gonna return us -1. And so that we know that our guess is actually higher than the number they have picked. So what we're gonna do, we're gonna place our right pointer to mid minus 1. So that will be mid minus 1 is 7. 7 plus 8. Again, we're gonna basically send that, find the middle. Middle would be basically 6 plus 7 is 13 by 2 is 6 point something, but 6 is the the number. Because of absolute division, we just ignore truncate everything after decimal, which will be 6. And now this time when we send 6, it's gonna return us 0. What does that mean? That means we got 0. That means we just return 6 as our answer. Now see, how many steps have we taken in order to find this? First thing first was basically finding this middle. That was one step, and then we were choosing, basically this became our window, next window. And then here we decided that 8 is not our number, and we chose to basically brought that down here. So basically one step plus one more step, and then plus this last step here, right? This is our last step. This was the step before it, basically this window. And then initially our first window was the entire range, right? It's getting a little messy, but what I'm actually trying to say is it took us basically 3 attempts to guess the number. 3 attempts to guess the number. I don't know why I'm writing it over here, but and so what is our time complexity, guys? Our time complexity, so what we have already seen this in the problems related to binary search previously, but what is really happening is we are basically, since we are bringing down our input to basically half each time, then what's really happening is to our input window, so 1 till 10, what's really happening is each time it just becomes half. This is how we break, and then we choose this, and then this also we break down, and this becomes either this or this. All right, so we are breaking down this window. So initially it was n, then it became n by 2, then it became n by 4, can also be written n by 2 to the power 2, and then it became n to the power 2 to the power 3, and at the end it will come down to our basically right guess, which is basically the window will become of size 1. That means that will happen basically at when we have, let's pick some number, 2 to the power k, and then it will become 1 n equals 2 to the power k. If we log both sides, then it will give us log n base 2, by the way, because this base is 2 here, and then this will be k basically if you log this as well, because k comes in the front if you log it. Okay, you wouldn't know if you ever studied logarithmic algorithm. So this represent, guys, our time complexity, and which is log n. Space complexity, really just it's constant. So this was just like showing the derivative to you, like why our algorithm is the best, and it's the GOAT algorithm, which is binary search, is log n always. All right, so I think now we know how we're gonna write our solution. So let's jump on to the solution. Looking nice. All right, so we're gonna choose a left and right pointer. So initially left and right would be, left would be 1, right would be basically n. Then what we're gonna do is have a while loop while L is less than or equal to R, right? And then we find out the middle. So mid would be, there is a one more way of finding the middle, that is basically you choose the left pointer and then add the half of the difference of basically this window between left and right. This is to basically protect if we are not basically overflowing our addition of left plus right values. You could do that as well. I think in most cases it doesn't overflow, it works, but just to be safe, you can talk about that to your interviewer. You know what I'm saying? That was bad. Okay, sorry. So now let's see what our APIs is giving us in response, which is if that would be, we're gonna send that mid to our guess, and this is our response. And let's check if response is basically equals to -1, that means our guess is higher than the number they picked. So we will bring down our right pointer. Since the guess is higher, we gotta search in the first half. So left will remain same. Left will remain same, and right will be basically mid -1. And L if otherwise, you know what, I should have just we can just honestly, this is better, like if response is basically 0, then let's just return the mid. This is better, right? If you found out your number was right, you just want to return that. Okay, and then else case would be basically the number, the guess we made was basically lower than the number the algorithm picked, so we're gonna go higher. So going higher means we wanna basically increment our left pointer to basically mid +1. All right, mid we already checked right here. If it was you don't want to like reconsider it. Okay, so remember these boundaries, and in the end, like I'm sure like we will guess the number, but just to complete the algorithm, we can just write, if nothing happens in worst case or whatever, like in anything, just return -1. All right, I think this is looking pretty good. Zoomed out. Let's try to run it on our example cases. And is there some problem? Yes, this is the problem. So it was mid +1. All right. Yeah, if it is taking longer than that, like there's definitely, you know, some problem. Okay, this runs. Now let's, okay, answer accepted. Let's write down the time and space complexity, which we already, you know, concluded. Right, so time complexity is big of big of, oh my god, my typing skills are really bad, n, and space complexity is basically constant. Space complexity is constant. All right, also, like there would be another way of writing this, is using just, you know, recursive. This is iterative, but you can write the recursive version as well. Then the space complexity, implicit space complexity would also be big of log n, since you're placing these each, you know, different calls, by the way. I'm sure, but this is easy way of doing it, so why not go with the easy way? Yeah, hold your ear like this rather than whatever. Yeah, this, not this. Rather than this. Okay, never mind. Okay, let's mark this solved and see you guys later. Bye bye.